All right. So good morning, good afternoon, good evening, ladies and gentlemen. Thank you very much for joining us here at this IoT Day Slam 2023 conference. We are going to go ahead and get started with our next segment here, which is our Mobility and Connectivity in IoT Center of Excellence panel, which is going to be discussing architecting for future scalability in IoT, some of the challenges and some of the solutions to look out for. It is my pleasure to introduce you to our moderator, who's also the chair of this Mobility and Connectivity in IoT COE, and Dr. Divya Gupta. By way of a brief background on Dr. Divya, so she brings over 11 years of experience, probably more like 13 now, since I was a couple of years old. But anyway, cloud computing, distributed systems, fault tolerance, big data analytics, consulting. Where do you begin? She's deep domain expert, and she's a fearless leader here in getting this group together and providing some great content flows over the last couple of years. So I'm going to turn the floor and the stage over to you, Divya, to continue to introduce yourself and the rest of your panelists.
Thanks, Kevin. So hello, everyone. We welcome you all to the Mobility and Connectivity Center of Excellence panel today. And I'm extremely pleased to be here this morning and lead our panel discussion. I would also like to welcome our very knowledgeable and experienced panelists. They are domain experts in architecting, deploying, and managing scalable IoT systems for different industries. But before starting our very informative and educational discussion, I would like our panelists to introduce themselves very quickly. I can start with myself. I am Divya Gupta, Senior Solutions Advisor at SAS IoT Global Division, and also the chairperson of this Center of Excellence. My day-to-day work involves working with various customers and partners of SAS and solving their business challenges. My prime focus is to provide them with scalable architectural design solutions for the edge, cloud, and also on-premises. I work extensively on operationalization of IoT streaming analytics, and in my experience, I have seen how challenging it is to design a scaling IoT system. So in our panel today, we will address these challenges and also provide some tips and solutions to keep in mind for achieving scalability in IoT. All right, let's go in alphabetical order. Over to you, Bob.
Hi, Bob Proctor, founder and CEO of Link Labs. We are a IoT technology company that provides asset visibility for manufacturing and logistics operations. We operate at scale. We process about 65 million location and sensing events a day. It's about 2 billion a month. We're in 1,200 customer sites. So a lot of experience with customers sort of driving scalability. And all the tools that Divya mentioned in her job portfolio also, we find in ours, from edge computing to on-prem connectivity to what do you do in the cloud and those types of things. So pleasure to be here.
Thanks. Jeff Bruce.
Yeah, thanks, Divya. Jeff Bruce Payne. I'm with Inmarsat. We're a global satellite communication operator and service provider. We provide remote connectivity services to companies and people all over the world. And my role is Director of Innovation and Technology Partnerships. I help our customers and integrators bring remote connectivity into their solutions for either primary purposes or for backup communications.
Todd Beets.
Hi, good morning. Todd Beets, Director of Solutions at Synadia Communications. So we're a company all around the NATS.io ecosystem, which is a wonderful and vibrant community. We're all about service-to-service communication in a mesh-like and global fashion with complete location transparency for developers. I have the happy position of being in a bridge role as Director of Solutions, part engineering, part consulting with customers directly in the community, and part product design to grow the NATS.io community and do wonderful and cool projects with our customers.
Thanks. Todd Spraggins.
Hi, Todd Spraggins. I'm with Oracle's Communications Division. We provide policy signaling session as well as OSS BSS to the CSPs. And in particular, we actually also provide internally to 13 different industries a communications-enabled IoT platform to help them better reach their markets through IoT transformation.
Thanks. Stephen.
Hi, everyone. I'm Steve Douglas. I head up market strategy for Sparent Communications, the global test, measurement, and assurance supplier for the communications sector, looking after the various communication infrastructure from devices, chipsets, through to the networks, network equipment manufacturers, and the end use cases, how they get tested, how they get assured in the commercial live deployments.
All right. Thanks, Stephen. Let's start with our questions. So the first question is that we know scaling IoT requires a great deal of technical and domain expertise. So what are the technical considerations to scale an IoT ecosystem and also keep the total cost of ownership under control? I mean, anybody can start.
Divya, I'll chip in and start with everybody else.
Sure.
I mean, I would say the first phase is good planning. That's probably the starting point. And the only reason I'm saying that is because we've seen in many sort of early IoT implementations is that without sort of a good futuristic planning, you run into troubles very, very quickly in terms of when you hit that scalability sort of time point or decision point. And of course, the planning covers a wide range of different areas. You know, it covers us from the radio spectrum that you're using, because again, you know, if you start densifying with more devices in the future, you may run into interference issues, so you want to be sort of aware of that. The manageability of the devices themselves, making sure that you can scale to actually manage them as they grow, and especially when you might have multiple generations of devices, which is another headache. You know, you might start with a specific generation of a device. You maybe, for reasons cost, they're maybe not upgradable in the field, and then suddenly you've got next generation devices, and you need to be able to think about how to deal with that. You got the cloud architectures as well. What's the most optimal cloud? Are you going to push everything back centrally to the cloud, or are you going to have edge distributions? So there's lots of sort of moving parts. I mean, that's just a few examples, you know, that you need to think about in the planning side to realize, you know, when you hit that sort of scaling opportunity, have you thought it through? So I would say planning sort of is the first one, and you rightly said you need skill sets across multiple domains for that.
Yeah, and also like interoperability is very important here. So as you mentioned, if there are new devices coming up, they will have different ways to work. So we need to be ready with that thing as well.
I'll add that I think it's important that the technical requirements reflect some of the human needs in this. We find that the human aspect is the most expensive aspect, especially as you start scaling. We're talking about all the touch points through the entire life cycle of your IoT deployment. So from the planning phases to the deployment phases to the maintaining phases. And the more humans have to touch that and it's not optimized for really mass, then you start running into issues. And so some of the things that we've been concentrating on is trying to decrease those touch points or making them the most efficient. A lot of times you see a lot of people have flashy, showy demos with IoT where the GUI looks all nice and point and clicky, but when you really go to scale, you need to be API focused with tons of automation in the background. You need to be able to have the ability to work with the entire supply chain so that device identities and SIM identities and those kinds of things are kept straight, exchanged in files, secure, and that realistically, you're not sitting there with people in the field having to enter in one device at a time. You know, things like barcodes or devices calling back home, you know, enable masses of devices to be brought online at a time and managed at a time. And so we always look at the human factors first and then drive really what kind of technologies are going to make that the most efficient.
Maybe I'll jump on Todd's. Oh, go ahead.
Oh, I was just going to agree and say I think it's partly human nature as well that at the beginning of projects, everyone sort of focuses on the happy path, even if they're doing a good job of thinking of people. And I couldn't agree more that IT is a people business. But it's sort of important to start talking about sad path early on, because it's easy to think about scale and increasing scale and the sort of speeds and feeds kind of mentality. Do I have the the bandwidth? Do I have X, Y, and Z from a technical point of view? And even if you're thinking about, device provisioning workflows, usually it's the sad path conditions, the sort of risk conditions that can kind of sneak up on teams. In POC 4, everyone realizes that something that was not even considered early on and didn't seem like it mattered becomes, a make or break factor in the success of the solution. So some real clarity on like what can go wrong, and start talking about the relative cost of those conditions, and then start talking about how that relative cost changes with scale, the number of devices or the number of people that need to touch something if this, sort of black swan event occurs, and that kind of conversation earlier.
Yeah, I
rather
think
than
at
later.
this point, it's not only about like the cost here, it's also like, we need to be ready to scale at each level, because there are different stacks in the IoT, and then
Yes.
we need to understand that what we require to scale this part, like for example, for gateway level. So how we can scale this, how we can scale like the edge processing or like the filtering of the data. So how we can do this scaling at each IoT level, IoT stack actually. So we need to start working on that from day one we go into the project, rather than, once we definitely start small, but we should be ready that once we will think of scaling, these are the things that we need to consider in future.
I think that's a good point, Divya. It's those bottlenecks that could actually cause the, scaling to fail, and identifying. And back to what Todd said, it is the I mean, I would call the rainy day scenarios the risks. Can you efficiently at the very early stages identify them and even model them so you know what they are? And that is a challenge, by the way, because coming from the test businesses, I know this very well. The test systems at scale isn't cheap. It's it's a difficult, and you need to think about ways then how you could actually test scalability, performance in a realistic way, and do that type of chaos engineering in there to highlight the risk and identify the bottlenecks. I think that's a little bit sometimes what maybe holds IoT back a little bit, because as I said, people maybe think it is going to be too costly to do that. Or it's too much hard work to try to think all that through. But I would advise people, I mean, there is ways to do that in a safe way. So yeah, I think that's a really good point.
Bob, do you want to add something?
Yeah, I'm happy to. I also realize you probably want to get to another question, but we break cost into sort of 6 buckets, sort of tags, infrastructure, data transport, cloud and applications, installation and setup, and maintenance.
Yeah.
And all of those at a demo level have one sort of set of costs. If you're running your initial sort of thought process and planning, and it ties back both the planning and the people side that came up earlier, if you start to say, well, what do those look at 100x or 1000x of scale? They all tend to be very different. I think that's part of the challenge of architecting the right kind of solution here. It's all those different categories of cost are very different at scale than they are at demo, and that's what causes a lot of challenges.
It basically.
Yeah, go ahead.
Sorry. I was just saying that when we do a demo level, it's different, but when we go actual production and actual scaling, it's totally a different story there, and we have to be ready to understand how it's going to scale, what can break here. So we need to be ready and understand the risks there.
Yeah, and I think this just calls into question, everybody around the table here or on the panel, has experience. The good news behind this is there's a toolkit that's available that is, there's a tremendous amount of architectural flexibility in how you design an IoT solution, from edge processing and everything to AI and automation of the human pieces and those types of things. So there's a toolkit to solve the scalability challenge. But there's a lot to get your arms around, and if you're on the outside saying, I've got to go do this, you need to find the right partner who can bring the experience to bear.
Right. So going forward to the next question, could you provide some tips to overcome this IoT scalability issues that we were just discussing?
I'll jump in with just a first thought and let the panel run. I mean, I think you almost always get forced to some level of processing at the edge. because you can't have a mindset of send everything to the cloud and I'll figure it out there, because the cost of data transport, data processing, all that kind of stuff are frankly too great. And so, I just put that down as you need to start to think about, what is actually actionable information, and where in my architecture can I determine that, so that I stop sending just mountains of useless information, through this sort of platform. Because mountains of useless information at scale is you're scaling a lot of useless stuff, and fundamentally that's part of the challenge.
Yeah, I think at this point, we need a better control over the IoT data pipeline and also what we are sending there. So we need to be, clear on what is our end results and what we are actually looking for. And then we should be ready that this data pipeline will be able to handle this, sudden increase in the data as well. So, and then if we do not have this proper control over the data pipeline, and then it can create problems. So it is important that we understand the right services, the right endpoints, and the messages that we are actually going to get and streamed either to the cloud or to the on-prem or any other platform. So we need to understand what is the actual pipeline and how these things can get affected when we have more data coming in.
Yeah, we found that pipeline has a lot of metadata at the various stages that people forget about, and we've found that that's been instrumental in us being able to control that pipeline in a continuous optimization feedback loop. And so a lot of people, they know the data has to go through all those different steps and stages and hops along the path, but each of those have management opportunities that if you instrument them and you collect that information, it can help you make decisions about where you can optimize along that path, reduce the data, increase the computation, those kinds of things, which aren't always self-evident by just looking at the data itself. Sometimes you've got to understand what the data encounters along those paths. And so that's been fundamental for us from a learning perspective in that area.
Yeah, agree.
Yeah, I would just add, I think a few of the points that were discussed in the prior question are really relevant here, right? The notions of planning is really important. Thinking forward, what does this look like at 1,000, at 10,000, or whatever level you need to scale it to, depending on what your business, what aspect of the business you're in. And also thinking through, what can go wrong. Those are a lot of things we see is particularly in remote environments in the field. When something goes wrong, if you haven't thought about that in advance, you can be in real trouble.
And Divya, I might, maybe some of the folks saw the really cool panel yesterday by I think it was the Identity COE, and it brought to mind that at scale, it's really important to look at sort of the data and the sort of connectivity points just for security services, for the whole life cycle, from provisioning to runtime refreshes and whatever the sort of topology is. But I think beyond just looking at sort of the business data and how I architect that and how do I deal with my edge location be offline, at scale, security and the security mechanisms become more and more of a factor, and maybe the limiting factor, not just for the obvious reasons like increased footprint or increased risk, but the number of things that can go wrong, or security being security in that chain of trust, the number of things that can happen, in the sad path or the rainy day scenario, just trying to be secure. So maybe there's not a rogue actor or something, but just your fleet of things in their normal process of either trying to bootstrap to security or refresh their security, that could become your limiting factor for scale.
Yeah, well said.
So,
yeah, that's true. Security is a big reason why things fail.
It's that pesky security when things don't work right.
Just
nothing
to add
is
to
working
that,
right, So yes.
Sorry, Steve, we didn't hear you.
Yeah,
Sorry.
but I mean, I think I was just going to say that's a great tip around the security, because labs and tests around the globe that you can security actually is one of the top areas that many people tend to focus on, because it's not just about being able to identify, and it's designing your mitigations is a key thing. And when you deal, because the last thing you want to do is you skill your system up and you do have a breach that brings the whole system down. So looking at where your mitigations are, that only allow about a small percentage did. I think that becomes sort of a key thing as well when you're thinking of scale. And also migration, the two that sort of go a little bit hand in hand, is that it's being also able to realize that you might start with a specific set of infrastructure or decisions, but you want to be in a position that when you grow up and start becoming bigger, that maybe they aren't the right decisions. You have a safe path that you can suddenly change your designer or architect. I think is a key thing as well. And I think that's something we see in many of the sort of these innovation labs where there's
Yeah. Sorry, Stephen, I think your voice was breaking a little bit, but yeah, I think I got your message here. I think everybody else as well. All right, Bob, do you want to add something, or anybody else?
With 8 minutes left, but through 7 minutes left, maybe get to the next question.
Okay, so this reminds me, while we were discussing all this, so it reminded me of what Werner Vogels, from CTO of Amazon, said. He said, scale breaks everything. So this kind of is true from our discussion. So yeah, on the same lines, could you share some of the real world examples when IoT scaling failed, and what were the reasons behind that, yet you could, pinpoint?
Yeah, I'm happy to go. We've broken lots of things, I guess. So we do indoor and outdoor location. On the indoor side, something that's very common is Bluetooth-based proximity. When you try to drive improved accuracy with that type of solution architecture, you put more basically listening posts around. Since they're uncoordinated, you try to drive more and more. As you add listening posts, you're just growing the amount of data you send exponentially. And I remember, one of our gateways cell phone bill went from, whatever it was, sub $100 to $3,000 a month, because we were just driving an enormous volume of unnecessary and duplicate data, through that. We've run into scalability sides. I think of the AWS architecture fundamentally has some intentionally, exponentially increasing pricing structures around, as all of us have probably experienced.
Yeah.
So you suddenly scale your solution, or you have surges in demand, and some of that can come from a customer, right, looking to run a lot of analytics all at once and drive a lot of data intensity. But you suddenly get a surge in data intensity, and then you see spikes in demand, and the way some of the hyperscaler sort of pricing structure is set up, that drives enormous costs on the back end and the cloud side. So we've seen that as well. So yeah, these are the kind of things that are sort of gotcha moments, for sure.
Yeah, so basically over provisioning and auto scaling basically brings more failure in that case.
That's right.
Yeah, that's true. And I also feel that, and I also seen that, when we kind of using different protocols, for example, this was one of the case when we used MQTT protocol in for a small project, it worked fine. But then down the line, it might not be the best choice because it has its own complexities, the latencies and security issues. And I think in that case, the right solution or the right way is to use REST APIs because they have several benefits, like, they have better security and ease to scale as well, and also very intuitive. So this is something that I learned from my own experience, that it's better to use REST APIs over MQTT when it is a very big project or scalable project. So
Yep, makes a lot of sense.
yeah, like very technical aspect, yeah.
Yep.
I have to also echo what Bob said. I think for a panel like us, it's easy for us to talk about technical failures, but I think business failures happen easily as well. And the cost containment, there with the on-demand pricing, and this happens even internally for us. So, a lot of our solutions that I deal with, it's internal cost basis and support of these applications becoming IoT enabled. And, some consequence, one day might change, egress might be free and ingress is what you get charged, but all of a sudden something happens to where you get a spike in ingress and a little bit of a bill shock, or you think you understand how things spin up during a collapse, and then all of a sudden you find that things didn't get cleaned up and you spawned a whole bunch of new pods, and boom, you're paying for triple the compute capacity. And so it's a new path that you have to be aware of in engineering. I think we've always looked at, when we used to design systems holistically before cloud, you used to always be conscious of trade-offs between one chipset or one bus architecture versus another, and what it would mean for manufacturing it. But I think it's been a little lax because you sort of think cloud is cheap and free or near free. And the reality is when you get to scale, you start finding that some of your decisions you made are going to really affect that. And then dynamically, what you're paying for one day, the pricing structure can change, and you have to make a decision. Okay, I'm already at scale. Is it worth the pain to change this so that I can get commercial correction? And people don't think of that. They're always thinking of the technical end of the failure and not always looking at what I consider business failures.
Yeah, I would agree. I'd also just highlight for the audience downlink. It's one thing to serialize and say, I'm going to upgrade the firmware on a device one at a time, and that works great for demos. But when you have 10 or 50 or 100,000 or 1 million assets in the field, your system can't walk through 1 million things one at a time. And it's a good example of how do you do bulk firmware upgrades, and how do you manage that? And your pricing structure may be all focused on, again, like ingress versus egress or uplink versus downlink. And suddenly, you have this, huge spike in need to upgrade firmware that you haven't really thought through. That particular edge case of I need to upgrade firmware times, thousands of fielded devices, and what does that do? Running data the other way, through your system.
Yeah, this is like when it fails when we have automated deployment and update cycles in a very big, large-scale implementation. So that's when it fails. And also, the load balancer sitting in front of the pods, as Todd Spraggins was saying. So that also is a point where things can fail when you have the load balancer. They just don't do the right job there, or we just scale them up, but still, that's also another technical aspect that can go wrong.
Yeah, just to add to what Todd was saying, the notion of a lot of people design assuming that the cloud is free or nearly free. We also see that in a lot of cases on the communication side of things, which obviously more relevant when you're talking about really remote communications. Things get more expensive the harder they are to get to, as a general rule of thumb. So you have to be mindful about all that stuff. And the things that Bob was mentioning as well before are really resonant in terms of thinking about being very mindful about what's relevant data for your use case and your business return on investment.
Yeah.
I was just going to add one other, because Bob triggered it in my mind, but it's recovery That actually is one that we see a lot of
Yes.
issues with. When the systems do go down, when you've got a small system and the devices all come back online, it's a limited set of traffic hitting it. But suddenly if you've got a large, massive system, and all of a sudden you come back online and those load balancers or their gateways are suddenly hit with all of these devices, suddenly communicating simultaneously, you cannot recover. So it's designing your recovery mechanisms as well. And that's where we see a lot of, especially in the connectivity infrastructure, where you have a lot of headaches if people don't think that through.
Yeah, I think that's a great call out. I was in my notes for this panel. I had some notes about that. That's the famous thundering herd problem. Sometimes we call it, the reconnection event if you have a failover, and so it's kind of designing for spikes a little bit. So, we talk about P99 in speeds and feeds quite a bit, but you almost need to apply that. You need to sort of assume worst case scenarios. What is my P99 for the SAD path, and can I survive this incident? Yeah, that's a great call out.
Who's seen the synchronized back off timer? Yeah, so it just never gets out of it.
Yeah. Divya, I thought it was an excellent point you brought up at the beginning. Just, I don't know how much time we have, but
we have plenty. Don't worry about that.
Oh, do we? Oh, okay.
Yeah.
I was like,
take your time.
The concept of layers in the different layers in the stack, which we all know, and I think, the audience members or customers of Synadia and our companies are trying to solve a holistic solution, but I think it's fairly common for different vendors and consulting providers to come in with their sort of expertise at their layer of the stack and sort of be challenged to find like where is the constraint, in what layer of the stack does it live? There's constraints in all layers, but like there's going to be some bottlenecks at certain layers, and how to approach that, as a customer who's designing the end-to-end solution and as a technology provider. Like, here's a recent example that kind of goes the point of, scale as well. Working with a customer who, for legacy reasons, they have a constraint that maybe for 2 or 3 years, they're constrained to run their edge locations on Windows PCs. Whether that's ideal or not, I won't editorialize, but they have a series of constraints that everything runs great, but then we're considering one of those SAD path events that, every once in a while the trucks rolls to deliver a new device, sort of on Windows. And for security provisioning, needs access to the network, and it can survive network intermittency or runtime, no problem. We dealt with that, but it's like at provision time, it needs to talk to the authority, provision itself, set up, and once in a blue moon, the human provider that rolls trucks to deliver the device delivers to like a dark store. No network connectivity, no anything. That's
thanks.
From my layer, I'm like, my layer, that's not a big deal. Oh, it could just, the service can restart as many times as it needs to until it can connect to the network and security provision. They're like, Todd, you don't understand. We're running this with Windows services and there's no repeat forever mode. It's like 4 times you're out. And what happens when you're out? So it's a scale issue, because if you have 10 edge store locations, no big deal. You tell a manager to go push the power button. But if you have, 50,000 locations, it could be an issue. So I thought it was a great point about the layering, right? Where's your constraints?
So we will move to our next question now, because I just got a message from Kevin. The time we estimated earlier was different. So okay.
Oh, okay. Yeah.
That's a little confusion here. So what are the various matrices to measure IoT scalability? So, just back to our scaling things. Well, how do you measure basically IoT scalability?
It's a tough one. There are a lot. I think we touched on here ends up being cost and total cost of ownership. That's clearly a big factor. But it also may depend on case by case, right? In some cases, it's how many of these do you need? If you're in a very high volume environment, how many does it need to support? Performance can be a metric, and performance can take many guises depending on, again, what the business problem and requirements are. There's an awful lot, I would say.
Yeah, that's true. I would go with, like, just two that I think are very important. One is the device scalability, and one is messaging scalability. So at the device level, we need to know what is the provisioning workflow and how we are going to do this automated deployment and the update cycle, the update workflow. And for the messaging scalability, I think we need to understand what is the message ingestion rate there, and what is also the failure rate, because we don't know how the messages are coming up. So there will be some failures as well, and maybe retransmission of those messages. So how are we going to handle that? And the latency that comes in when we have several messages coming across. So if we can understand, like, what's going on in both at the device level and the message level, once it comes to the platform for analysis or something else, or even at the gateway and from the physical IoT devices itself. So I think these two matrices also makes the first level of matrices when we start with IoT data.
Yeah, I would add that infrastructure tends to limit the number of devices. The infrastructure in the data pipe and the communications layer, it has intrinsic limitations on how much devices and data throughput they support, and you need to understand what those are. And if you need to bump up against those boundaries, how are you going to solve that problem? Right. On the cloud and device management side, to just kind of dot your I and cross your T even further. I mean, I think of it as a many-to-many problem now, that you can have multiple devices associated with one asset, and you can also have many assets associated with one device. And then if you think about what happens over time, you could have edge tags and those types of things that get broken, or they get associated with a new asset. You can have assets associated. So how tightly coupled is your database architecture between an IoT edge device and an asset, or the thing that you're trying to gather some information from? If it's a kind of very brittle one-to-one database architecture, that cannot stand the stress test of things break and change. And that's another area to sort of poke on.
Sorry, Todd. I was just going to say the one, just a quick one, the one that's maybe we're seeing coming to the fore at the moment, and many of the customers and many of the markets is energy efficiency as a metric that now needs to be really looked at, especially when you scale systems, in terms of what's not just obviously from a sustainability perspective, but obviously from a cost perspective these days. And that's becoming a really sort of hot topic at the moment, in terms of how you can better, to your point of view, if you can characterize maybe the traffic mixes, the behavior, the data behavior, you can get an idea potentially of what that sort of maybe cost will be. But we're definitely at the moment, that seems to be one of probably the biggest demand we're seeing at the moment from systems is, can we get a more accurate understanding of the overall energy cost, energy efficiency as the systems scale up, what that might mean.
Yeah, agree. Yeah. I mean, this is like my first question whenever I get into with the customers. What is your message rate? What are you dealing with? So, and how many devices, and what's your future here? How many devices you foresee? How the thing's going to turn out later? So we need to understand like all these. Todd, Beets, you wanted to say?
Yeah, I was just going to jump in. This is kind of the Synadia and NATS thing. So it's and jumping off what folks were saying about connectivity to the cloud and understanding those rates, and for us, it's a lot about understanding sort of the communication meshes and trying to keep local communications local. So if I have an edge location, but I have 100 microservices that need to be talking together, keep that traffic local to that area, and be very cognizant of the traffic that needs to go back to your cloud service. So it's really a topology challenge of communication. in messaging between services. But it's very powerful if you can do that. So not everything has to connect to your really expensive and slow and intermittent cloud from a connectivity point of view. But most of your traffic could stay local if that's kind of your use case, and only traffic, telemetry, and business service things can go back to your clouds when necessary. But keeping that transparent to the developer. You don't want to burden your developer to understand where everything lives. The developer should just be able to have that conversation and let your IoT infrastructure essentially figure that out.
Yeah, that's right. All right, so we talked about the security here. So one question here is why strong security is difficult to scale effectively in a scalable IoT architecture. So what are, the problems with that? Todd, you can start with that because you brought the topic of security there.
Yeah. Well, I think it's security is a service, right? And so with the service mentality, trust authorities, various types of credentialing systems, et cetera. Those are all services. So it's a little reductionist, but it boils down to the same problem. Your application services need to talk to a security service, and there's even often more of a strict sort of flow or saga in that communication, especially for bootstrap, provisioning lifecycle type steps, and chain of trust. So that really you need to. Also, I think this is the people aspect, because as we know, there might be in a large organization or in a large project, there's a service owner. They are security service owners, and they have their own technology stack and constraints and superpowers. And so understanding how their services talk to your services and the happy path and the sad path, your services being at the edge or an IoT device is pretty critical. And having that discussion like on day one of the effort versus day 1000 right before go live or is super important for that reason. And frankly, in an enterprise environment, sometimes there's such a large investment in certain security services and a desire to leverage those for good reasons. But those services might have been, in the best case, they're born in cloud, but they weren't necessarily born for, high scale IoT and edge computing. So really understanding where those constraints live is critical in the security realm.
In the security area, we've been finding that it's becoming obvious and necessary to try to expand the zero trust paradigm thoroughly through everything, through every link, through every communication between microservices. The only thing is at scale, you do have to be cognizant of managing that, and as well as the cryptography burdens, because even hashing at that scale between everything can get a little burdensome. But it goes to alleviating a lot of the human issues. We had left this exposed because we thought it was behind a nice ironclad, internal piece, but then you find out that oops, that was crunchy and someone crunched through. So those are the kinds of things that get alleviated, but they open up their own problems. I think the industry is still trying to figure out exactly what is 100% zero trust look like, end to end, and how do you manage that?
Yeah, totally. We've all been there where, I've always called it the phone home scenario to an identity authority. Somebody will say, oh, just for every connection you make, go and consult this blah, blah service. And you're like, you're kidding me, right? I'm going to phone home that won't scale at all. But it often leads, maybe the more interesting point for the audience is, I think we talk about localizing data, and maybe that data is cache data, moving that to the edge, closer to these operational services at the edge. Often that data ends up being security related data, like cached assertions that have a TTL or whatever, just so that you can sort of control, the phone home beast of making all of those calls to your central authorities. So there's this sort of localized data element that I find pretty fascinating and sort of leading edge about security. How do you consult your authority, centralized authority, every once in a while, and then sort of keep a cache of those, assertions local, so you don't have to incur that expense all the time, and you can live through outages in network connectivity? Pretty critical.
Perfect. Thanks, Todd, for your valuable insight on this. So we already have reached the top of the hour here, so we don't. I think we have to conclude our panel now. So thank you. Thanks everybody for joining us today. Thanks to all the panelists here. Back to you, Kevin.
Thank you.
No, thank you all, as usual, for putting on another amazing representation for this mobility and connectivity center of excellence. It just goes deeper and deeper every time. We have run out of time, but we've got a few minutes before the next session starts, so everything is building along nicely there. And I just thought I'd express my gratitude for all that you guys are doing to help advance and advocate, the mobility and connectivity COE. We have big plans for it this year. We hope to see as many of you in person at the June live slam event at SAS for the panel that we're going to be doing there. I know it's coming up pretty quickly, but June 21, 22, we'd love to build on the great content flows here in person. And then we'll talk about the rest of the year in September and December thereafter. But again, thank you very much for being a part of this. We'll bring the session to a close, folks, and we will whiz you all off to the next session. Stay in touch. All the best. Take care. Bye.
Thank you.
Bye-bye.